Despite the large numbers of clerks employed today, sufficient clerks are still hard to find. With full employment, the security of clerical work does not offer the old attraction. But trade is becoming more competitive, so clerks are in even greater demand to provide statistics from a mass of data so that management can grasp the changing factors and act accordingly. To fulfill this modern need came LEO, the first automatic office in the world. Electronic computers are not new, but LEO was the first designed for office work. Since 1953, it has been employed regularly on accounting, stock and cost control, statistics, and, of course, payroll. LEO is fast and flexible. It can test the feasibility of the information that is fed into it and check the accuracy of its own results following orthodox accounting principles. LEO can be installed anywhere. It does not require air conditioning, having its own ventilation system. It is supplied complete with equipment for stabilizing the mains voltage. LEO Mark II has 4 channels for input of information and 4 more for output. This particular installation is using 3 input channels, 2 coupled to punch card readers and 1 to a punched tape reader. Its output can be routed to card punches for machine reading or any of the normal printing devices. Any other suitable form of input or output can be coupled. LEO is set in operation from a console. It is here that its performance can be monitored. At the factory of LEO Computers Limited, new requirements are investigated by programmers, methods men and electronic engineers, and at the right time they are crystallized into a development plan. In the laboratories, the development plan is transformed into a logical scheme involving hundreds of electronic circuits. Having been working on automatic offices since 1949, this development team know what is wanted for regular, routine operation in commercial and industrial offices. Once the outline of a new scheme has been established, it is handed over to the designers. Their task is to work up the details into drawings and circuit diagrams. Built into the electronic design is the know-how that comes from practical experience of automatic offices. When designs are checked, tracers make final drawings. The mounting of the electronic components require a great deal of purely mechanical design. To ensure that all parts are interchangeable, each must fall within definite engineering limits precisely determined in advance by the designer. This is ensured by making jigs. Using the jig, hundreds of parts may then be produced within the design limits. The assembled racks are wired for interconnections between units. Manufacture of the electronic circuits begins with small packages carrying a few valves assembled by hand. Every soldered connection is inspected for good workmanship and freedom from dry joints. The packages are then incorporated into larger units. The larger units are electrically checked connection by connection against the designer's drawings. Thus, each part has been checked mechanically and electrically before it goes over to a new LEO. At the new LEO, individual assemblies are set together for functional electrical tests to prove that the performance of each circuit conforms to specification under normal and marginal conditions. An electronic computer for office work must be absolutely reliable, because delays are intolerable in an office working to a deadline. Hence the checking and inspection at all stages. LEO has been designed primarily for routine office work, but is perfectly capable of mathematical work. And between office jobs, night or day, it does calculations for a wide variety of interests. For the Chancellor, LEO worked out the PAYE tables for 1955 to 56 and printed them off in one night. For the Institute and the Faculty of Actuaries, LEO calculated tables for life assurance and annuities. For the Ordnance Board, LEO worked out range tables. For Handley Page, Leo carried out flutter and stress calculations for faster, safer flight. For Ackwood Statistics, Leo analyzes the findings of market research. For the Coal Board, Leo worked out the classifications in the fight against pneumoconiosis. For the British Transport Commission, Leo worked out the shortest distance by rail from each station to all the other 4,000. This would have taken 50 clerks 5 years. For an hour a day, Leo belongs to its engineers for maintenance and testing. The voltage, normally kept to the operating figure, is made to fluctuate. Any valve or other component which can operate in such conditions is certainly fit for another 24 hours useful life, and if it cannot, then now is the chance to change it. Special programs, designed to be much more exacting than normal work, are run through to test all components and circuits up to their designed limits. Now the machine is ready for the day's work. Typical of the routine office problem is payroll. Every man at the Ford Motor Company, like anyone else, expects to be paid on time and paid correctly. Such numbers would have always been a clerical problem. But nowadays, clerks are scarce, and there's a lot more detail to be worked out. The rate differs from man to man, and so does the number of hours worked. Overtime rates vary. Each man is taxed differently. Some men are repaying loans by deductions. Most contribute to the sports fund. Quite a few allow deductions for national savings. On top of all this, any item is liable to change at short notice. Normal timekeeping staff deal with the clock cards daily. Other people collect alterations to code numbers, rates of pay, deductions, and so on. The clock cards and alterations are then sent off to the Leo automatic office 20 miles away by the Ford Motor Company's regular courier service through London. Once the information reaches the automatic office, it is put into a form Leo understands. In this case, punched paper tape. As a check, another girl produces a second tape from the same cards. The first tape is used as a control on the second girl's machine. This machine, besides punching the second tape, produces a printed tape marked in red at each place the checker has made a correction. In this way, a scrutineer can make sure that corrections have been done properly. When all is ready, Leo is given its operating instructions. Then each man's rate of pay and other personal data and the running records produced by Leo last week are fed in. Concurrently, new information for this week is fed in from the paper tape. Leo's speed is such that less than a second later, the actual payslips print out in duplicate. Payslip after payslip, produced at the rate of 5,000 an hour. Simultaneously, Leo is able to print a payslip for one man, whilst doing the calculations for the next man, and taking in the data for the man after that, dealing with 3 men at the same time. Whilst all this is going on, each man's running total card for next week is being punched. Immediately the last payslip is printed, Leo prints off reconciliation figures, cash dissection totals, and statistics. Back at Ford's pay office, the pay sheet is split into individual payslips. All that Leo has not done is to put the payslips into the envelopes together with the money and hand it to the man who earned it. National insurance information has been provided by Leo, and also national savings. It has also prepared management statistics, printing such items as overtime hours and cost, bad timekeeping, average earnings by grades, and so on.